Hey, let's finish the quiz review. Look at number 3 here. Helium is pumped into a spherical balloon at a constant rate of 25 cubic feet per minute. At what rate is the surface area of the balloon increasing the moment when the diameter is 16 feet? So we have we'll be dealing with the volume formula as well as the surface area for a sphere. Okay, so let's see what they give us. Helium is being pumped into a spherical balloon at a constant rate of 25 cubic feet per minute. So cubic feet per minute, cubic feet represents volume per minute, will be a rate for volume. So we know dV dt must be equal to 25. And let's see if we can make sure that this remains a positive. So helium is being pumped into a spherical balloon. So we know that balloon will be increasing in volume over time. So positive 25 is the correct value for dV dt. Hey, at what rate is the surface area of the balloon increasing? So we're looking for surface area's rate. So surface area is S, but we're looking for the rate of that. So we're looking for ds over dt. The moment when the diameter is 16 feet. So diameter is 16 feet. But the formulas that we're dealing with are in terms of radius, so we'll divide the diameter by 2. So 16 divided by 2 is 8, so that's we're going to adjust the 16 to get it into a value that we can use for our formula. All right, so we're trying to find ds dt given dv dt and radius, so we know we're going to have to work our way down to the derivatives. So v becomes dv dt, 4/3 pi, coefficient stays, r cubed becomes 3r squared, but we're involving r as derivative, so we attach dr dt. Right. Simplify some more, we get dv dt equals 4 pi r squared because the 3's cancel out, dr dt. And we'll stop there for now, and let's look at the surface area derivative. So s becomes ds dt, 4 pi r squared becomes 8 pi r dr dt. Okay, so we have our dv dt and we have our ds dt. So let's see how we can proceed to find our solution. So we're given dv dt, so if we plug that in here, as well as the radius, which we have being 8. So if we plug those in, then the only variable that's missing is dr dt. So we can solve for dr dt by plugging dv dt and radius in for this formula. And once we find dr dt, then we can use that information to plug in here along with the radius, which is still 8. And we can use those pieces of information to plug in to solve for ds dt. And that will be the path that we're going to take. Okay, so it's important that after you have all the variables and information in front of you, that you kind of plan out how you want to piece this puzzle together. Okay, so we're going to start with dv dt, get to dr dt, and from there we can find ds dt. Okay. All right, so 25 plugs in for dv dt, 8 plugs in for r. So if we clean this up a bit, we get 25 is equal to 4 pi 64 dr dt. Divide everything over to the other side. Dr dt equals to this fraction that simplifies to be 25 over 256 pi. So we have dr dt. We can use that to plug into the ds dt formula. So dr dt gets replaced with 25 over 256 pi. R, radius, gets replaced with 8. Combine all that, simplifies to be 25 over 4. The pi's cancel out, and we have our reduced fraction of 25 over 4. Surface area, so that's square feet. Rate of change per minute, so square feet per minute. All right, number 4, 17-foot ladder is leaning against the wall. The bottom of the ladder is being pulled along the ground away from the wall at a constant rate of 5 feet per second. So we know x will be moving to the right, and then y will be going down. We're looking at the the rate of change of this triangle here. So as the ladder is falling and pulling to the right, this x value will be increasing over time. And as the ladder is falling, this y value of this triangle will be decreasing over time. Okay, so we see a right triangle here. We're going to be using Pythagorean Theorem to relate these three variables. So x squared plus y squared equals h squared. We find the derivatives, and we can see what variables they give us. So 17-foot ladder, that's the hypotenuse. The bottom of the ladder is being pulled away from the ground. How fast will the top of the ladder be moving down the wall? So we're looking for dy dt, because that's y represents the top of the ladder. How fast it's falling, that's dy dt. When it is 8 feet above ground, so when y is equal to 8. So h is 17, y is equal to 8. We can use Pythagorean Theorem to find the x value, which is 15. Okay. Dx dt is 5. That's the horizontal rate of change because the ladder is being pulled away from the ground. So dx dt is going to be 5, and let's see if the positive 5 makes sense. So as the ladder is being pulled away, that x is increasing over time, so positive 5 does make sense. We want to maintain that as a positive. dy dt is what we're looking for, and dh dt is the rate of change of that hypotenuse of that ladder, which is 0. So we have that as 0. Okay, so we have 6 variables, and 5 of them are found. So all we need is to solve for dy dt. So we plug everything into our differential equation. So 215 times 5 plus 2 times 8 times dy dt is equal to, and all this goes to 0. And we just simplify. We get 150 plus 16 dy dt equals 0. Subtract 150 from both sides, divide by 16, and reduce our fraction. We get negative 75 over 8 feet per second, and that will represent our dy dt rate of change of the top of the ladder moving down when the ladder is 8 feet above ground. Okay, part B. At what rate is the area of the triangle that is formed by the enclosed region, changing, the rate of the area changing when the ladder is 8 feet above ground? So we're going to use the same scenario as what we did with part A, so all this information is still valid, but now we're trying to find the rate of change of the area of this triangle. Area of a triangle is 1/2 base times height, so 1/2 base is x, and the height of the triangle is y, so 1/2 x times y. A becomes dAdt, but if we want to find the derivative of two variables being multiplied together, we have to go through product rule. So f prime g plus f times g prime. F prime, the derivative of 1/2 x is 1/2 dx dt, the x disappears. G, so we bring down the y, plus f, so 1/2 x, times the derivative of y, dy dt. So once we have our dA over dt formula, we can just plug everything in. We have dx dt from the previous problem, so 5. Y is 8. X is 15. And dy dt we just found from part A, which is negative 75 over 8. We plug that in. We combine terms, use our calculators to simplify, and we get negative 805 over 16 square feet per second.